Have you ever fallen asleep in one of your classes at school, or at least felt like falling asleep? If you have, why did this happen? It's because the lesson was boring, right? Well, science is one subject that doesn't have to be boring. There are so many exciting experiments that can be done that demonstrate scientific principles that you just can't help having fun while learning. Hi, my name is Josiah Brown, and I'm in the Happy Homebodies 4-H Club. And today, I'm going to tell you how learning about science can be fun by doing several different scientific experiments for you. The first experiment I'll do for you today is called the egg drop, which demonstrates Newton's first law of motion. The second experiment I'll do for you today is called the leak-proof bag, which teaches us about something called polymers. The third experiment I will do for you is called the straw through the potato, which helped teach us about the power of air. And the fourth and final experiment I will do for you is called red cabbage chemistry, which will help teach us about acids and bases. So let's get started. The first experiment I'll do for you is called the egg drop. I'll begin by filling this glass 3/4 of the way full with water. Then I'll take this pie pan and put it on top of that and center it as best I can. Then I'll take this cardboard tube, and you can guess where I got this from, and put it in the middle of the pie pan over the glass of water. Then I'll take this egg, and this is a raw egg, not a boiled one, and put it on top of the cardboard tube over the glass of water. Now the goal of this experiment is to get the egg from the top of the cardboard tube to the glass of water without touching the egg, the cardboard tube, or the glass of water. The only thing I can't touch is the pie pan. So what do you think I need to do to get the egg and cardboard tube out from underneath the egg? Well, I'm going to apply Sir Isaac Newton's first law of motion and smack the pie pan out from underneath the cardboard tube. Are you ready? 1, 3. Hey, it worked. Now let me tell you why it worked. Sir Isaac Newton was one of the greatest scientific minds in history. He formulated 3 laws of motion, which tell us why objects move the way they do. The egg drop experiment demonstrates his first law of motion, which states objects that are in motion want to stay in motion, and objects that are stationary or still want to stay still unless an outside force is applied. So since the egg was not moving from the start, it didn't want to go anywhere. I applied enough force to the pie pan to smack it out from underneath the cardboard tube, and its edge hooked the cardboard tube and made it fly out from underneath the egg as well. Then the force of gravity took hold of the egg and brought it straight down. Now, according to Newton's first law of motion, once the egg was in motion and wanted to stay in motion, but the glass of water interrupted the egg's fall and gave it a safe place to land. So, we also really got to learn about gravity too, which, as most of you know, is the natural force which causes objects to move towards the center of the earth. So let's move on to our next experiment, the leak-proof bag. All I'll need for this experiment is 5 well-sharpened pencils, a quart-sized bag, and water. Oh yeah, and these paper towels and this tub in case this flops. So what do you think will happen if I stab one of these pencils through this bag of water? Will the water leak out all over the place? Will I get wet? Will you get wet? Well, this is the interesting part. As you can see, I can stab the pencil all the way through one side of the bag and halfway out the other. See? And I can do the same with this pencil, and this pencil, and this pencil, and of course this pencil. Isn't it amazing how all the water stays in the bag? So what scientific thing can we learn from this plastic bag with holes in it? Well, it's a thing called polymers. A polymer is a chemical compound in which each molecule is made out of two or more simpler molecules strung together. The plastic bag is made of a polymer called low-density polyethylene. According to science teacher Steve Spangler, the polyethylene molecules are like freshly cooked strands of spaghetti. The end of the pencil easily slips between and pushes apart the strands of spaghetti, but the spaghetti's flexible property forms a temporary seal against the edge of the pencil. Of course, when you pull the pencil out, the polyethylene molecules have been permanently pushed aside and the water leaks out. So let's move on to my third experiment, the straw through the potato. All I'll need for this experiment, as the name indicates, is a big raw potato and some straws. Now, the goal of this experiment is to get the straw through the potato without bending or breaking the straw. When you first look at it, you think, this can't be done. Well, let me try it out for you. Hey, it worked. Now let me try it with this straw. That one worked too. There's a secret to doing this. See how I have my thumb on the end of the straw? By doing this, I am trapping air inside the straw. This demonstrates the scientific principle of air compression. The trapped air molecules push together, giving the straw strength and keeping it from bending or breaking. Now watch what happens if my thumb isn't on the end of the straw. The air is simply pushed out the end of the straw and the straw bends. So let's move on to my fourth and final experiment, the red cabbage chemistry. I'll begin by putting 3 or 4 big cabbage leaves into this blender and then turn it on high. And I'm going to have to plug it in. Next, I'll take the purple cabbage liquid and pour it through this strainer to filter out all the big chunks. Doesn't cabbage juice smell wonderful? Next, I'll take the purple cabbage liquid and put it in these 3 cups and fill them 1/2 full with cabbage juice. 1, 2, 3. In the first glass of cabbage juice, I will pour vinegar. We can see that it turns more of a reddish color. In the second glass of cabbage juice, I will pour a teaspoon of laundry detergent. and stir. We can see that it turns more of a greenish color. The last glass of cabbage juice I will leave alone to show the original neutral color. What we are learning about here are acids and bases. Acids and bases are opposites. Acids have the lowest pH level, and bases have the highest pH level. The pH scale goes from 0 to 14, with 0 having the most acidity, which is a word to describe acids, and 14 being the most alkaline, which is a word to describe bases. We can tell if a substance is an acid or a base by using an indicator. An indicator is a chemical that changes color when it comes in contact with an acid or a base. So our cabbage juice is an indicator. When we poured the vinegar into the cabbage juice, it turned red, indicating it is an acid. When we poured the laundry detergent into the cabbage juice, it turned green, indicating it is a base. So let's try a couple more. And I'll just fill these 2 cups up. So what do you think will happen if we pour orange juice into the cabbage juice? Right, it is more acidic, so it turns the cabbage juice red, indicating an acid. Now, let's try ammonia. It is more of a base, so it turns the cabbage juice green. If we poured something into the cabbage juice and nothing happened at all, it would indicate that the substance is neutral, just like milk or water. In conclusion, today I have told you how learning about science can be fun by doing several different scientific experiments for you. I did first the egg drop experiment, which demonstrated Newton's first law of motion. I did second the leak-proof bag experiment, which taught us a little about something called polymers. I did third the straw through the potato experiment, which taught us about the power of air. And I did fourth red cabbage chemistry, which taught us about an acid and base indicator. I found all the experiments for my presentation today from the book Naked Eggs and Flying Potatoes by Steve Spengler. I also found information for my presentation today from the website www.sciencecompany.com and the books Men of Science, Men of God by Henry M. Morris and the Thorndike Barnhart Intermediate Dictionary. Are there any questions? The question was, how did I become interested in this topic? Well, I'm homeschooled, and me and my mom, we did this book for school, and it was my science, and we really liked it, and so I decided to do a presentation on it. Are there any other questions? If there are no more questions, then this concludes my presentation.